Hey, welcome back. We're still looking at graphing linear inequalities. Right now we're going to look at standard form. So just a quick reminder on our symbols. Watch the symbols. It's or equal to, solid line, not equal. It's just are less than or greater than. And then paying attention to, do I shade above the y-intercept or below the y-intercept? Okay, all those things still apply. Okay. The difference with standard form is we want to convert it to slope-intercept, right? Standard form's a little more involved to just straight up graph it. But if you convert it to slope-intercept form, you have your intercept, you have your slope, and we just did that, right? So zero out your x value to move it to the other side, divide by the coefficient of y, and then pay attention because remember, if it's a negative coefficient, our symbol flips because now we've changed the story a little bit. All right, and then you graph it like a slope-intercept form inequality and use the calculator to check our work. So here we go. We have x plus 3y is greater than or equal to 3. Okay, so first thing is let's get this switched. So I'm going to rewrite it over here so I have some room. Okay, so we said first we want to zero out the x. And now when I write it over here, I'm going to write it off to the side because these are not like terms. They will not go together, guys. Do not put them together. It's not 3x minus 1x. It's not 3 minus 1. It's 3, a constant minus variable. So they're not like terms. All right, that's zeroed out. We're left with positive 3. Please don't ignore your sign. Positive 3y is greater than 3 minus x. That are not like terms, so they stay like that, separated. Okay. Then we said divide by the coefficient of y. The coefficient is 3. And I'm going to divide each piece, and I'm going to show it separately because that helps me break apart things. All right, this reduces to 1. Y is greater than or equal to 3 divided by 3 is 1. And then negative, that's a 1, negative 1 over 3. So this is going to be negative 1/3 x. Okay, I can pull that out, that negative 1/3 in front of my x. Okay, cool. So I know this isn't exactly mx plus b, but I should be able to know, hey, this part is my slope, this part is my y-intercept. The constant is the y-intercept, right? So I start at 1, and then I use my slope. Negative 1/3 tells me to go down 1, and then the positive 3 tells me go right. Okay, remember the negative is only part of either the numerator or denominator. Just put it with the numerator unless you need to swap roles. Okay, so here we go. Down 1 over 3, there's a point. Down 1 over 3, there's a point. If I reverse it, up 1 over 3, it should still keep me in line here. Cool, up 1 over 3. Awesome. Okay, then I come and I look, and this time I'm going to look at when I converted to make sure, did my symbol flip? So this is or equal to, so it's going to be solid. So I'm going to draw my solid line, and remember, please use a ruler. You don't want crazy Miss Valente lines because those are not looking pretty right now. All right, we have that, and then the final thing is shading. So I look at this whole part, I have y is greater than or equal to, which means shade above the y-intercept. So I come here, above the y-intercepts here. So here is my solution. Anything up here would make this a true statement, right? Okay, so let's go see which of these is true. Negative 3, positive 2. Ooh, that's right on the line. Is our line included in our solution this time? It sure is, because it says or equal to, solid line. This is part of our solution. Awesome. Okay, 1, 3. So I go 1, up 3. Hey, look at that. That's part of our solution as well. Okay, and then we have 4, 5. So if I go 4, up 5. Okay, this time all of them were in our solution. They should all make this true, right? And so if I were to just test that really quick, if I picked one of these, so let's do 1, 3. So that's x, y. If I plug them in, x is 1 plus 3 times y is 3. that should be greater than or equal to 3. So if I test this, 1 plus 9 is greater than or equal to 3. 10 is greater than or equal to 3. That is a true statement, so it works. Okay, let's do one more. All right, so we're looking at the standard. 2x minus y is greater than negative 3. So 2x minus y is greater than negative 3. Our first thing is convert this to slope-intercept because that will help us out. So 0 out those x's. I have positive 2x, so subtract it will get me to 0. I'm going to subtract it off to the side. These are not like terms. I have constants. I have variables, so they don't go together. So this zeroed out. I'm left with negative y. Don't drop your sign. Negative y is greater than negative 3 minus 2x. And then we said we divide by the coefficient of y, which is negative 1. So negative 1, divide by everything by negative 1. Okay, so this is positive y. Ooh, we had a negative coefficient, so we have to flip our symbol. Okay, so that's going to change now to less than, and then negative 3 divided by negative 1 is positive 3. Negative 2 divided by negative 1 is positive 2x. Okay, now we have our pieces. So I know 3 is my y-intercept. So I'm going to go ahead and plot that on my y-axis. That's where I start. And then I know that positive 2 is my slope, right? So I'm going to change that, though, to 2 over 1. Remember, whole numbers over 1. That tells me go up 1, to the right, 2. So up 2 over 1, up 2 over 1. And then I run out of graph, so I'm going to reverse. Down 2, left 1. That still continues the pattern. Down 2, left 1. Down 2, left 1. Down 2, left 1. All right, I'm going to come look. Oh, why did it choose yellow? That's horrible. All right, so we're going to look at this. It's not equal to, so that's a dashed line. So we're going to dash this line. Please use a ruler, nice and straight. Okay, so there's my line. That was a pretty good one, guys. I'm impressed. All right, and then we also looked that its y is less than now from my conversion, so I'm going to go down. Remember, look here, it said greater than, so always look at your conversion. That symbol flipped, so I do less than, which means my solution is down here, right? Less than the y-intercept. So everything over here, right? Everything that's there. Now let's go on the hunt, see which points are in our solution. So we have 5, 1. So to the right 5, up 1. 5, 1 is part of our solution. Then we have 1, 0, 1, and no vertical movement. 1, 0 is in our solution. And then negative 4, 5, negative 4, up to 5. That is not in our shaded region. Sorry, man, you are not part of the solution. Okay, so that's how you graph inequalities. Get it to slope-intercept, plot it. Is it solid or dashed? Do I shade below or above my y-intercept? And that's all based on the symbol.